Because I have literally zero slides, but I have an interactive presentation, so I hope you won't mind that. So as Leah mentioned, my name is Georgi, and I'm an international student at Berea College. I'm currently interning at Kashmir Foundation, and I've been interning here for about 10 weeks, and this is actually my last day. So, yeah, and I've been working on the Snow Leopard project. So what I have prepared for you is a kind of an interactive problem-solving experience. So let me define the problem for you, and then we're going to try to solve it using AI altogether. So we're trying to use AI to help people in Kashmir mountains who work with snow leopard preservation as well as other animal preservation. We're trying to help them do their job better and faster. So what we have here is a folder with a whole bunch of images, right? So as you can see here are like 120 different images, right? So the purpose of the program and the algorithm I'm developing is to sort those images into appropriate folders according to the animal that is present within it. So let's say we take a look through a bunch of images. So you can clearly see that there's a snow leopard in this image, right? So right now, everyone who's working in Kashmir to help sort those images, they all have to like go through this by hand and like literally move those images into specific folders. Our purpose is to design an algorithm that could do it like almost instantaneously on its own, right? There are 8 different animals that are primarily featured in those images. Here we have some goats, right? As you can see, this is not a drone project, and for the purposes of this event, we decided to not do a drone project and rather do like an online camera trap project. So
can I just add something?
Mhm.
It will eventually integrate drones, but we couldn't start with drones on this project.
Yeah, obviously because Kashmir does not allow any drone flights for obvious reasons. And as you were saying, the way we capture those images is those are like on-land camera traps. So they're motion activated and they're non-invasive. So the animals are actually kind of curious about them. Those camera traps don't move. So they just treat it as part of the environment. So they don't really, they're not afraid of it or anything like that. So that's how we are able to capture so many different images. So as for the problem, now I've defined the problem. So how do you guys think, does anyone have any idea, how would you approach this problem? Anyone?
Wait, could you like put it through some sort of machine learning thing to identify like which animals is which?
Right, so that is a correct approach. So one thing that I would tell you is that a lot of those animals, they evolved to blend into the environment. So even sometimes for the human eye, it's sometimes hard to see those animals. So it would be especially hard for an artificial intelligence to see those. So the approach is correct, however we need to slightly modify it. So there is this neural network architecture called YOLO, which does not mean you only live once, it means you only look once. So the whole point of it is like you just take a picture and you separate it into squares that could potentially have something in them, right? They don't necessarily have to have something in them, but they have certain probability of having something in there. And then you classify that square of an image and you show like, oh, this square contains 99% snow leopard. So let me demonstrate to you how it works. So I started this internship 10 weeks ago, and during those 10 weeks I was able to train and build this network. So any one of you could actually also do it because I didn't have much prior experience before that. So, okay, so now let me show you how this works. So let me show you first the images, right? So those are the images we're going to be testing today, right? So those are snow leopards, that's a yak, right? And let me run some code. So this is what the network looks like in code. And know this is very confusing right now, but just don't pay attention to that. So let's run the network. So since this is already trained, all we have to do is just specify the name of the image you have to put in. So let's say here, we want to test the 36 underscore something image, right? So we put in 36 underscore 0271, and there you go. And it's going to take some time to run. I need some elevator music right now, but I don't have
I
any.
already have a question for you.
Yes.
What was the threshold thing that you did there?
Oh, so the threshold is like the certainty of the network, how certain it has to be in order to display the output. So you can see here it says Snow Leopard 84% sure and Yak 34% sure, right? Let's say I put a threshold of 0.4%, right? 0.4. That would mean it has to be 40% sure in order to display anything. So in case if I were to put 0.4, it would only display the Snow Leopard because it was 84%. As opposed to Yak, which was 37, which is below 40. There you go. Alright, and let me show you the actual image, what it looks like. Here you go. So, as you can see, like it drew a box around the actual leopard. So, this would be very helpful for everyone who's trying to work with preservation. Like, I could easily, now that I have drawn a box and know what the animal is within the picture, just easily move it into the specific folder, and now they don't have to sort it by hand and stuff. Let's run through a couple of more images, right? What was the name? Right. Let's do this one. Alright, so yeah, so it is also generalized to all images. So the purpose, when we're training a neural network or any other machine learning task, we have a whole bunch of data and we have a model and we put the data through the model. The purpose of our exercise and what we're doing is to make that model not just remember everything that we gave it, but also be able to generalize to the broader scenario. So let's say I were to give it different kinds of images. My network should be able to understand that this is also a Snow Leopard as opposed to, just being confused by it. So the instance when generalization does not happen is called overfitting. And sometimes that happens, quite often it happens actually. Okay, let me show you what that image output was. And there you go. So you can see what happens, right? However, this approach also has some problems. As I mentioned before, some animals are supposed to blend in with the environment, and also some animals are very, very small. So even for a neural network like that, it is extremely hard to classify it and detect it, right? So in tandem with this approach, I designed a different approach as well to pick up all the leftovers that YOLO did not pick up. So I'll give you guys a hint of that approach. So it uses motion detection as well as change detection, right? So does anyone have any ideas how would motion detection help us in this scenario?
Would it separate the pixels that are not moving with the pixels that are moving and then look at only those pixels?
Yeah, correct. So let's look at some images, right? So you can see the images here are within the same cycle of the animal, right? So it's just like one animal moving around, like those cameras are motion activated. So that animal is moving around, but the environment remains still. So in the case of camouflage, and when the animal is blending into the environment, as soon as it moves, we're able to capture it. So what my algorithm does that I developed is, let's say we start from here, right? This is our first image within this folder, right? It compares this image to the next image and then to the next, and to the next. As long as it does not discover a big change between the images, this means that, oh, those are all the same animal, because they're just like moving a tiny bit. But as soon as it compares this picture to this picture, you can see, oh, there's a huge change in the scene. That means the new scene has started, right? And then after that, within the first scene, we perform just simple motion detection, and we're able to crop out the moving animals. And then on that, we perform a classification. So we run a simple neural network to classify those segments of the image. And then as whatever they get classified as, that means that's what's in that cycle, in that scene. So let me show you how that works. So this is the code I wrote. It's a whole bunch, but don't get scared. Alright, so this is just a graphical user interface, very simple. So right now I'm going to select a folder where I have all my images. Then I'm going to select the folder where I have my model. And I'm going to start the algorithm. Alright, so while the algorithm is running, it's going to take some time, so I can take some questions if you have any.
How many lines of code do you write for?
Okay, so in total, I mean, there's like 400 here, and then plus around like 400 or 500.
500 lines?
Yeah, some I'm not quite sure.
Is it all in Python?
Yes.
Can you expand this to go to a specific animal, or is it always going to be a general animal?
So you're asking like specific snow leopard, for example. So in order to do that, I would have to perform more work. So for example, we would have to up the resolution, right? Because there's so many different, like the best way to do that, I would say, would be by their patterns in their body, right? So in order to perform that, we would have to up the resolution of the images by quite a lot, and we would have to make our network itself bigger as well, because the bigger the network, the more different patterns it can pick up. So sometimes small networks cannot really detect the things that bigger networks can do. So I think it's definitely possible, but it would require more work, and also way more data, which we did not have in that one.
And that is actually the ultimate goal of the project.
Yeah,
To
so-
get like individual actual snow leopard. And then from that, we will be able to track how far the snow leopard's actually traveled. So if we know, if we see this snow leopard, let's say in Kazakhstan, and then we see it in Mongolia, so that'll help us now know how far the range of that snow leopard is as well. And then there are a lot of regulations that could be rewritten for different countries, because there are 12 different countries, and they kind of try to cooperate for the snow leopard project. So we're hoping with this new platform, we would be allowed to kind of help change some of the regulations to allow them to have more space for the snow leopards to now be saying, yes, 100%, this is where it is, this is how much range they need.
Any more questions?
Georgie, why do you crop the images?
So the reason why we crop the images is because the images themselves are like almost 2,000 by 1,500. And sometimes the animals only take up a small proportion of that image. And for neural networks especially, that noise that is the background of the image can sometimes overpower the actual presence of the animal. So for example, pikas are literally just tiny rodents, and sometimes you cannot even see them because they just look like a rock, right? So there's absolutely no way a neural network would on its own pick up on that, right? Because they're just so tiny, so small and insignificant compared to the larger picture of the image that you have to perform motion detection. And as soon as that pika moves, you know, oh, there it is. So you crop it out, and then you can perform better classification data. Any more questions?
Would this process take place on the drone, or would it be down on the ground?
So at the moment, this is all on the computer itself, because as Aaliyah said, we cannot fly drones within Kashmir, because it's a disputed territory between India and Pakistan. But ultimately, it with a programming language of your choice, I would recommend either Python or R. And then usually you would use some kind of library, either TensorFlow, PyTorch, or Keras. And then you just write some code and put some data in it, and then it works like that.
What library are you using?
At this moment, I'm using Keras and TensorFlow. Yes.
Is Python like the snake?
I mean, there is a snake that is Python, but this is Python, the language. Any more questions from not 8-year-olds?
You've already done some Python coding, remember?
I know.
You're
Yeah, some snake coding.
Wait, what would be the difference between using Jupyter and using Python for machine learning?
So Jupyter is just a developer environment for Python. So Jupyter is not a programming language; it's just a place where you code Python. So I don't think there will be much difference.
Oh,
Usually, developers prefer Jupyter for data science projects because it allows you to run code in chunks, as opposed to PyCharm where you have to run the entire module at the same time. Because sometimes you have to load your data, and you don't want to load it all over again and again and again, because that would just take too much time.
Jupyter Notebook is one of our most popular use cases.
Yeah.
It's really light running. Like I said, you can run a lot of different machines.
Yeah. Also, you can use Google Colab, which is Jupyter Notebook, but on Google Cloud, and it's free. And I would encourage you, if you want to get into AI, use Google Colab as your starting point.
so you're saying Jupyter is just more convenient for testing?
Yeah, Jupyter is more convenient for running your projects because you can simply run a segment of your code one time, and it will be the output of that segment will be saved for a long time, forever until you exit the Jupyter. Yes.
So the scenario that you were in, you were using 7 to 8 pictures as your input?
No, so the scenario that I'm showing you, I'm using 120 different pictures. So, okay, so does anyone have any more questions? Alright, so let's get into what happened here, right? So we had a whole bunch of pictures, and suddenly 2 different folders pop up, right? So I wrote code to do all this. So let's see what is in this folder. Right, there are more folders. Wow, okay. Let's go into the first folder. Let's go into images. Let's go into here. Okay, so here's what happened, right? So remember how I described first we separate this same scene and then we crop out the animals? So this is the result, right? So here's a whole bunch of kind of cut up snow leopards pictures. Now you can notice that they're all the same size, and that is because when you're training a neural network, you want all your images have to be the same size every time that you input an image. It has to be the size that you predetermined beforehand. So yeah, so let's look at more folders. Let's look at this one. Yeah, so here's some goats, some baby goats. So before I show you the results of this, I would like to talk to you about the limitations and power of AI. So far I haven't used any AI, right? I just have used simple image manipulation and sorting and cutting and stuff like that. So I would like to talk how sometimes AI can be misleading. Sometimes people just give it so much trust and they say, oh, we just use the network and it will solve everything. So that is not the case, right? Sometimes you have to actually think about why it's failing and what's going on, right? So sometimes it can be very powerful, but sometimes you can give it too much trust and it will give you wrong results and you won't even notice sometimes. So now let's look at the results. Okay, so here it generated, how many is that? 9 folders, right? So let's look at goat, for example. Right, so you can see it was able to correctly classify some goat images, right? So you go 4. Okay, let's go, I don't know, snow leopard, right? Oh, there you go. So there's a whole bunch of snow leopard images, right? But now let's look at when AI makes makes a mistake, right? So let's look at the fox. Oh, look at that. There's more snow leopard images inside the fox folder than there is in the snow leopard folder. And this might seem confusing to you at first, but why do you think? Does anyone have any idea why it happened?
Was there a fox image at night with the reflection of the
So that's quite close, actually. So the reason why this happened is let's go back and look at this batch, right? At the very first one. So look here. So there's a whole bunch of different images, right? And they're all 200 by 200 pixels, right? Look, for example, in this image, you cannot even see the snow leopard pattern, right? It's just like a gray mass with some white dot eyes. So you could see how an unintelligent machine, which AI is, like, it does not have general intelligence, it's only limited to what you teach it. So you can see how this could be confused, like a whole bunch of gray images could be confused with a fur of a fox or something like that. So that's why the AI classified this whole folder as a fox folder and moved every single image within this folder into fox folder of an output. So you have to be very careful when you're designing an AI to understand its limitations and understand how to solve it. So for example, if I were to solve this problem, I would increase the resolution of the images by twofold, right? I would make it 400, 600, something like that. Then those snow leopard patterns would come up even better, and then the network would be able to understand better what is going on. In addition to that, I would probably add more diverse images. I would add more snow leopards at night to my training set, or more foxes during the day, or different color foxes, different color snow leopards, stuff like that. Yeah, so I guess what I'm trying to say is it's not as simple as just creating a network, tossing a bunch of data in, and just gathering outputs at the other end. You have to also think from AI's perspective what it would understand and what it would not understand. So, any questions?
How many animals did you train to classify?
So in this particular case, I think it's 8 animals and background, which is just noise.
Did you upload a selfie?
No, I did not. I actually should try that.
Yes.
I'll probably be a goat. I think that's good. Yes?
So you mentioned that lack of data on the snow leopards is part of the challenge because we don't have, so how do we tackle that element of machine learning on endangered species where we don't?
That's a great question. So we've actually thought about this problem as well. So let's look at our pictures again, right? So let's see. So as you can see, there are just a whole bunch of pictures during the night, right? Imagine if you could transform those night pictures into day pictures. Now you may say, that's crazy, right? How do you do that? But there's a field of AI called generative adversarial models, which allow you to transfer styles, as in like the coloring of the image. Like if you have Snapchat filters, right? Or like Instagram filters or whatever, those filters are all style transfers. So imagine if we could transfer the day style onto a night image and night style onto a day image. It would effectively double our data set, right? Or for example, we could move the snow leopard around within the image. So let's say I would crop it from here and put it in here. AI would treat it as a different picture that's effectively the same. And there are other things you can do. You can do data augmentation. So you can rotate this image, flip it, do all kinds of things, which should not result in decrease in accuracy, because the whole point is for us to generalize, right? So it should not matter for the network if this image is horizontally flipped, or maybe moved a bit, zoomed in, zoomed out, stuff like that. So that's a great question. Thank you. More questions? Yes?
Are there any other systems that would be better for detecting the biometrics of the animals so you can differentiate them easier?
What do you mean by biometrics?
Respiratory respiratory rate, heartbeat, movement speed.
There are for sure like cameras that will allow you to do that.
Are there lasers that will do that?
I'm sure there are. I was not provided any of that, so I'm not sure. I'm not sure how I would. I mean, yeah, I guess that's true. I'm sorry.
I'm just asking, I was curious.
Okay. I think Ron can answer that question better.
So,
What was the question?
aren't there lasers that can detect like heartbeat and respiratory rate and things like that from a distance?
Well, we would have to, one of the things we will end up doing, actually, is redesigning the camera trap itself. Currently, the camera trap is just a basic camera, and the only capabilities it has is to detect motion. It's stationary, one directional. So one of the things we're looking at doing is, once we develop the AI for this, then we redesign the camera trap system itself, integrate this, and then we're looking at using drones to collect the image as well. So once we redesign it, we can integrate other sensors, but then you also have to always look at cost as well. For nonprofit conservation, how much money do we have? One of the things I always try to do is keep things open source and low cost, because I know that once it would go into a production phase for other conservationists need to purchase it, it would have to be affordable. Otherwise, it's just not gonna work. I mean, right now, just a basic camera that they're using in the field costs $800. That's like no intelligence, just motion detection. And then there are other types of cameras that can get more expensive, but we can totally redesign this for under $100 if we, use like a, let's say, simple something as a Raspberry Pi camera, and then you can integrate a few other sensors with it as well.
Well, what if you expand the biometrics to the pictures that you have, like the distance between the eyes on a snow leopard are not gonna be the same versus another animal?
Right, yeah. So yeah, you're right, there are many different ways of figuring out how to use
I think that would
something.
make it a lot cheaper, but you wouldn't upgrade your camera, you just like.
You would be able to use some type of online capability with it. And that's why we're looking at redesigning the camera trap, because I think we'll have a lot more capability with something like that than we would if we just later on looking at it.
So another thing, something on the next level would be, instead of taking just single shots and frames, would be a continuous live video, which YOLO in general performs way better on a video rather than on just a whole bunch of images. Because it's like one single fluid motion, and motion detection as well would perform better if there was a video instead of just pictures, because the motion is fluid and it's easier to detect. Any more questions?
I have a general question. Like, how is this project funded?
It's not.
It's not. So, we're actually a 100% volunteer nonprofit organization. So this is like my passion project and my retirement project, and this is what I love to do. And then I have amazing people like Georgie, Ola, Emily, and Fawn all over the world that come and work for me for free.
Okay.
Or not for me, for the cause of helping animals.
Yeah, I love doing this.